Okay, hello everyone. We are in week 12, the first session of the week 12. Today we are going to continue. This week we are going to finish the chapter 6. So today we are going to cover 6.7 and 6.8 part of the chapter 6. And then the rest is going to be on Wednesday. We will finish and try to practice and get ready for the exam. So today what we are going to see is related to some changing that we can do to the database that we have, like the one we later learn on chapter 2, like the insert function, update function, and delete function. And also we will see something new that we call it as a view or view definition. So let's get into it. Okay, so again, for changing the queries, for changing the database that you have, sometimes you need to update your database, sometimes you need to uh, delete some part of the database as a rows. Sometimes you need to also insert some extra rows, extra data to your database. Okay. So in that case, we have these three functions: insert, update, delete. So like the previous sessions, we will just see the initial syntax and then we go to the example. So make sure to have your window ready. I don't know. Okay. Okay. Let me have this windows ready. Also, we are gonna mostly work on your credential, but for sure in MySQL. Okay, so in order to creating a copy of the current table that you have, so that's a function for it. So we use it with the create table function with the new table name, whatever it is, and then we go with the select statement from the old table that we have with whatever conditions. So this is the way that we can do the copying of the one table to the new table. And also we can just also insert some data, some rows to the table. So we have this one, insert into the table, whatever table it is, whatever attributes, and what are the values. And also you can also do the multi-value, insert more than just one to the table. So let's see some example for it, and then it's gonna make more sense for us. So for the first one, we are going to create a copy of the customer table. We would like to name it as a customer copy. Okay, so let me just so as we mentioned, in this case, the function that we have is create table. Okay, so the create table, whatever function we have, and then the name, which here is the customer copy, and as we call it as a alias for it, and then we have to select all the column from customer table. Okay, but the point is, at this moment, we need to also address the database. The database name is Redcat. So when we said from redcat.customer, it means the customer table from the Redcat. So it's gonna just select from the whole Redcat database. It doesn't matter. So deny access. What is it? What does it mean? Deny access. Let me see what's the issue. Yes. Yeah, you worked. Okay. Let me just fix this one first. Mirror display. Did you all run on your side? Okay, just and always make sure to have this part in your code. So sometimes you already have the table. So make sure to have always this line to the first part of the code. So drop table if exist and the table name. So in this case, we are not going to have any error even if we have the customer copy or whatever table already existed in our database. So when we run this, we can see that the first line also works because I myself, I created the table before this class. So that's why I need to have this one. But since you're just doing for the first time, you're not gonna need it. But again, it's always good to have this type of syntax when you are creating a copy in your database. So again, create table, customer copy as select all the column from the Red Cat customer. So right now, we just create a copy of it. So if you want to check it, we can just also see the table copy. So we can see that the table is already copied. And right now the table name is customer copy. So this is the way that we can just create the copy of a table from different database into the database that we have. So that's how we can address it. Now let's do another thing. Add yourself as a customer number 20,000 into the customer copy table. Okay. So in this case, the function for it that we have is insert into, which the table name is customer copy. And since you probably don't remember the attributes, I will tell you, we need to put some value for the customer ID. So let's see that. The customer ID, first name, last name, whatever, and then that's the structure. So first we need to mention all the column or attributes, and then the values is exactly one by one. So customer ID 2000, first name Nick, both, and the rest is related to the address, city, whatever. So in order to check, we can just select the distinct asterisk from the customer copy and where the customer ID is 2000. So in this case, I can also run this. So I can see right now the customer already imported. So that's the how we can just insert one row our current table, whatever table we have. Again, the function is insert into, then the table name, then all the attributes that we need to import, then the values. For each column, we have to put the values. If we, for example, doesn't have one of these values, there is a mismatch between the number of columns and the number of values that we are going to insert. So this time we would like to create a new table, which we would like to name it as a sale item archive. And then we want to copy all sale item with the sale price greater than 150 into the archive using subquery. You see here, we mentioned the subquery. So if you saw the subquery in exam, for sure you need to use a subquery. And again, if you practice more, you will see at the end of the day that using subquery most of the time is more efficient in comparison with the just a join function, like the one I mentioned in the last week. So if you were not in the class, make sure to watch the videos. So again, for creating a table, the function that we already learned about it is the create table and whatever name that we have. And then we have to address all the attributes with their specific features. Is it a numeric or whatever? So let's again, the first line, always I would put it, drop table if exist, the whatever table name it is. So right now the table name is sale item archive. I would like to have the sale ID as an integer primary key, product ID integer, item size decimal with one decimal point, and also quantity integer, and then the sale price also 10 characters with the 2 decimal points. And then after creating this one, we are gonna apply that condition, which the condition is copy all sales item with the sales price greater than 150. Okay, so in this case I would say insert into the table that I have sale item archive, select all the column from the red cat sale item table when sale price is over 150. So again, after creating, I would go with the insert into. So this is the way that we can import multiple rows, multiple data to the table. The previous version, since we just entering one specific row, one specific data, we had to address each column by related values. But here, first we created a new table, which is the sale item archive, and then defined all the column, and then we would say, okay, now insert to this table that we just created. From which table? From the sale item table in the Red Cat database, where the condition for us is sale price over than 150. So after this, we can see the table is going to be just 30 records. So we can also just again use the select asterisk from sale item archive table. Now run query. We can see that 30 items here. As long as you just learn the structure of the code, how the code should be written, it doesn't matter anymore what number of items you would like to import from which table to the which table. There's a main structure for it always. And also, you can use it whenever you want. Any question for this insert section? So we learned first how to copy a table, and then how to just insert one specific row to a table or one specific data to a table, and also how to import more than just one data, multiple rows of data according to some condition. Here the condition is sale price over 150. Good. No question? Good, good. So the second one, which is the update, we can update whatever values in our table. If we don't mention, for example, based on this condition, the table is going to update all the related columns. For example, if we have the list price, okay, and if, for example, we said, okay, just update the list price for 5% for me, increase it to the 5%, it's going to make all the values for the list price column, it's going to increase all of them 5%. But for example, if we say where the date of the sale of the item is, for example, after June the 2015 to June 2016, then it goes to just those values that meet this condition. So if we don't mention in where condition, it's going to apply for all the values. If we mention, for example, in this specific condition, then it's just going to update some specific one. So here, update all customers from states of Washington, states equal to WA, all capital, into the customer copy table by setting the state of WA just with the first one, capital. So we would like to update just the alphabets of the Washington. So in this case, the function for it is just update and the table name, and then we would use the set statement and whatever condition we have. Okay, so in this case, we have update from which table, customer copy table, set the state WA with just the first one capital, put all these all capital letter of the WA with the just this version, W with the lower a. So in this case, if you have already created the table, the customer copy table from the previous part on your side, we can see that again, 92 records affected. So right now, if I select let's say asterisk from customer copy where the state is equal to WA. If you're using this together. But right now it doesn't affect because you already changed it. Did you create the customer copy on your side? And does it work for you when you change the? Okay, cool. So right now select. Yeah, customer copy. Is the full customer copy? Yes. So right. Yeah, especially when it starts with the select, it's gonna give us. So right. In a previous one, it did, but I was also surprised why it didn't let us this time. Because here, let me. Where is it? Okay, like this one that we did. So here we have the insert one. Really? Let me. So it did for me. Maybe you are missing something. Did you create the customer copy first? I mean, from this one. So we can also just run all of them together, I would say. First, uh, creating a customer copy from the Redcat database customer table, then insert to it, then let's also select. So, okay, this one is not an error because we already imported the data, but at the end we can see that this one is here. So we already created this one, and then it is. So as you see, these two works together. So right now we have the customer the 20,000, but this one is also. This is the previous one. Again, we had created table and then select all of them. Okay, so let me. So again, this is the way that we can update right now without any condition. We are just updating the state column. Whenever it shows the W, to replace it with just this one. But the second one, create a copy of the product table, name product copy. And then update the list price for all product to reflect to a 5% increase. So for the copy version, it's easy. As we just learned, create a table, which we call it as a product copy. As the select asterisk from redcat dot product. So this is the way that we can just create a new table or copy a table. And then we need to update the product copy table, set the list price equal list price times 1.05. So again, the first part always is good to have, especially when you're practicing. And all the syntax already posted on D12 for you. Let me run it on. So again, drop the table. If exists a product copy, create a table, name it product copy as the select asterisk from the redcat product from the redcat database, and then let's update the product copy table by which condition set the list price equal to list price times 105. So 413 record got affected. If we have here, for example, where condition, for example, for a specific date, it will just update those that meet that range of condition for the, for example, a specific date. Otherwise, it's gonna just again update all of the values beneath the list price column. So after adding and updating, we have the delete type of queries. So delete structure is again look like the insert, look like the update. So delete from whatever table where some specific condition we have. Okay. So again, delete is gonna remove all the records under that specific column. But if you have some extra condition by where function, it's gonna just remove those rows that meet that condition. So this one, delete all customers in customer copy table from states in the four corners: Utah, Colorado, Arizona, and New Mexico. So let's start with the delete from the table name, which is the customer copy, the one that we created before. And then we have the condition where state, which we have the list of state, we use in parentheses, and then UTCO, UTCO, easy, and what is it, New Mexico. So right now, 206 record just got deleted. Those that the states are Utah, Colorado, Arizona, New Mexico. So technically, it's also almost same structure as the update function. That one updates, but has a set statement after update. This one is gonna delete from whatever table according to some specific condition. Delete all products from product copy table with the list price below $10. So you tell me, how should I start? Delete from, what is the table name? Product copy. So what is the condition for it? Where the price is below $10. So where list price below, is this correct? Quotation? Or sure? No, it is correct. No, it is not. No? This one is the numeric. For numeric, we don't use quotation. That's it. So 11 recorded, just 11 record just got deleted from it. It's gone forever. Yeah, there's no. That's why you need to always make sure to work on the copy of that table. If it's okay, then apply for the version. For example, if you work right now on the Red Cat one and just put the product here, so technically you are gonna delete it from the, what is it? I'm not sure. To be honest, I haven't tried because I didn't want to mess up with the data. But you just did it by mistake, am I right? No, the one that you did and it didn't let you. You wanted to create it. What was the error that you received? Probably. Okay. Okay. So probably they had some. Mhm. So now the views. What is the views? Imagine you have the table, like the sale table. No, let's make it more. You have the employee table, okay? And then you have the name, whatever, you have the SSN, you have the salary, okay? Now, for example, you want to use this database, this table for some of your, let's say, uh, employees, and then you don't like them to see the SSN and the salary of the whole employees. Okay, in this case, it is a good idea to have another table that first of all, it's a representative of this table. So if you change whatever in this table, you need to be automatically applied to that table. And then make sure to limit, for example, some of the column or attribute. For example, you would like to just exclude the SSN and the salary from that table. That probably the most of the employees have access. Okay. In this case, we use the view function. So the view technically creates a virtual table, create a copy of your current table virtually. So it's gonna be permanently in your database. It's gonna be there. But the point is, again, it's limited. There are some specific column on it. But the good point is, whenever you update this table, it will automatically update the view one as well. So the view table is not gonna store data. The employee table here, it's gonna store data for you. This one is look like the mirror. Just shows whatever you're doing here, but with some specific, for example, uh, exclude some specific column. So the way for it, the syntax for it is this one: create view, the view name, whatever name, and then you need to use the as one, and then select from the data that you have. Let's see the first example, and then the rest, I need you to do that. So create the view of the customer table that includes all the first name, last name, city, and the state fields. Okay, so again, the first line look like the table that we have. Drop, we in the previous version we had drop table if exists. Here we would say drop view if exists. Okay, and then create view. The name of the view is customer view. As now select first name, last name, city, state from the Redcat customer. So right now we are having a view, which is again table, but look like a virtual table, but it is permanent. So it's gonna stay forever in database unless you delete it. And then starting with the create view function, the table name, whatever attributes you would like to have from whatever database you have. So if I run this one, so right now we just created a view. Now I can just easily treat this view as a table. I can request a query from a table. I can do anything with this one. It exactly looks like the table, but again, if you would like to, for example, insert, just pay attention to this one. You cannot insert any data directly to the customer view, okay? If you wanna insert data, you need to insert to the customer view, customer table, sorry, and then automatically it's gonna reflects on the customer view. So this part from the book, let me go. Mm. You can always run this type of syntax. I just want to show you something. Let's just delete this one for a second. In whatever credential you have, this is in the book. So there is a syntax select asterisk from information underline schema dot tables. Okay, this is the just general syntax. It's in the book. When you run, you can see whatever tables in your current database. So here you can see that some of the table they named as a base table, like the, for example, sale table. This is the base table, the one that we created and inserted the data into it. Some of the table named as a view, okay? For example, this one product brief, which is technically a view version of the product table with some specific column. If we update that view table, that product table, it's gonna update this product brief view as well. But let me again. So as I mentioned, right now this customer view, right now the customer table changed to the customer view. So I mean the view version, it just have these 4 columns. Again, if I update the customer table, whatever, it will automatically reflects here. So we can see it here as well. So again, view is just a like a virtual table. You can do whatever query with the view as well. But again, the main point is just to restrict some part of the table when you would like to, for example, present your table to the other people that they don't have, for example, let's say, full authority to see those information. Example like the salary, like the SSN, those stuff. So let's run this one. Create the view of the employee table that includes the first, last name of the employee as well as their hire date. So first of all, the table that you would like to create is from the Redcat, the employee table. We would like to have the first name, last name, what is it? And the hire date. So we start with the create view, okay? And then what is the view name? Here we can just name it, for example, employee view. View from what is it? The Redcat employee. So employee view again, we should have the as, and then first name, last name, hire date, uh, from Redcat employee. Redcat. The reason that I'm asking you to just do the coding on your side, and as long as you practice more, you type more, you will learn better. Just by watching this, I think it doesn't work. So again, I will always start with the drop view. If exists employee view, create a view. The view name is employee view. And then as select first name, last name, hire date from the Redcat employee. So now we can see that view is created. So no, what you got the error? Sorry, MySQL, your credential. So again, this one, you can just treat this one as a separate table. So right now you can see that this is the view version. Employee view, it just have 4 columns. And then the next table is the employee from the Redcat table that it has all the column, SSN, I don't know, email address, whatever. So if I edit, for example, update the first line, the first part, the employee 5, automatically it's gonna show also in the view version as well. So is it clear what is the difference between the view and the table? Yes? Don't make me to miss him that he is not here today. Reply to me. He's always replying. Good, thank you. He is in Florida right now. I don't know. Is it playing some concert or something? Okay, so another example. Let me first create the copy. Create a view of the customer table named customer view that includes only the first name, last name, city, and state fields from customers in Utah. Almost similar to the previous version, but we have some extra condition, which is where the state is equal to UT. So I would start with the create view, the name of the view, let's say again, customer view. As select, what are these? First name, last name, the city, state, and then from redcat dot customer table where the state is equal to UT or Utah. Again, I start with the drop view if that one exists, and then create view. So customer view as select this attributes from the redcat database, the customer table where state is used. So technically, if I select S3 from, what is it, customer view, I should just see those customers that, what's happened? Here? Oh, okay, sorry. Okay, cool. So we can see that the view version is just the customer from use. Again, depends on the condition, the application. For example, you have a, let's say, company with multiple branch in some state. And for example, you would like to also create some table for that state. So instead of, for example, creating a new table, probably if you have the new table, if you want to also insert data in the current, in the main table, and also the second table, it will probably make some error. But if you have a creative view of it, so whenever you update the first table, the base table, automatically it's going to reflect on the, what is it? The view version, so there is no error for it, and then for sure is more safe. The one thing I forgot to mention on the delete one, in the delete section, it is always important to make sure the order of the delete. For example, let's say you have the sale table, you have the customer table. Okay, sale ID here is the primary key. Sale ID is, what is this key in this table? Foreign key. So right now, if I delete some rows here, okay, which the sale ID is a primary key, it will automatically also be deleted from this table as well. But on the other side, if I delete something from here, it's gonna create some error here in this table. So we need to always make sure, according to the primary key, foreign key, if there is a connection between these two tables, if you would like to delete it, you need to always make sure to delete from the one that has the primary key. Otherwise, the other table is not updated correctly. Just this one I forgot to mention. So let's have the last one and then go to the assignments. Create a view of the employee table called employee view. To the last one, yes. No. Yes, that's it. Again, create a view of the employee window, select first and last name, hire date from the database. So almost the same. Just we have the hire date this time added. So we can just again run it. So this time we have first and last name and hire date again from the employee table. So that's about the view and also the adding, inserting, updating, and deleting. Let's see some assignments. The database change operation. So just pay attention to these assignments because it's look like the chapter 2 that you have to create the table first and then apply. So it's totally explained as you learn in chapter 2 problem. In order to make modification to the database table and records, you need to have your own database schema. Okay, so in the following problem, you need to use your student credential, which automatically already a student credential, and then you need to first create a table, then execute whatever information you have. So no, this one is the red cat one. It's just gonna show us the relationship between, yes, yeah, exactly. This is the one that we should create. So create the new table, name it purchase 61. Again, all these are recorded, so we can just go back and watch them because we are close to the end of class. I would prefer to just show you this since we have exam next week. Okay. Create the table, new table, name it purchase 61, and then insert into the purchase record of the employee 61 that were made after Christmas in 2014, between December 26, 2014 to December 31. Use between, use data format YYY Okay. So first of all, if we just open it in an advanced editor, we can see that it will automatically show us in the student credential. So this is the one. Let me just put this one. And then we are creating a table like the one just we learned. Creating table purchase 61, name it as a purchase 61. and then as select asterisk, select all the column from which database, Redcat, what is the table name, purchase, then where employee ID is 61 and purchase date between this date, 2014, 26 December to 31st December of 2014. So if I just test the query, right now it doesn't show for me because I have already this one exists. So I could, for example, just mention drop table if exists, and then name it as a purchase 61 now test query. So first of all, this condition already met and 7 record effect. Okay. I just don't use the drop one. I just wanted to show you. So is the code clear? The logic of the code? Now let's see this one. Create the new table. Name it purchase item 61. And it's no, this one is purchase item 61. This one is purchase 61. And employee 61 again were made in this time. And the main point is it's a purchase item. So it's from the two different tables. So it's from the purchase and purchase item. You see, we have to make a connection between these two. That's why for this one, we have two ways. One subquery, the other one use the normal join function that we learned. You need to connect these two tables together, purchase item and purchase table, through the purchase ID key. But again, this is the subquery version, okay? So in the subquery version, first we are creating a table. What is the table name? Purchase item 61. As select asterisk from the Redcat. Purchase item, we name it as a PI. Where purchase ID should be something. What are those? Those that we are querying them from this subquery. This time select purchase ID from Redcat, again purchase table, where employee is 61 and the rest of the condition. So technically, first of all, these are these correlated or uncorrelated? In order to find that something is correlated or uncorrelated, we mentioned that if we can run it independently, it means they are uncorrelated. So this one, we can just easily run it. Purchase ID, purchase table, everything is already available, so we can run it. So these are uncorrelated. It doesn't matter. But the main point is the result of this one is gonna be multiple purchase ID. So technically, this is the list. So it's gonna work. It's gonna. I mean, this query works based on this purchase ID. Also, I also put the join version as well. So as we saw last week, technically they are the same. So here we have the purchase ID. We have to, extract purchase ID from here and put it here. Here we would say, okay, create the table, purchase ID 61, and then we are selecting just the purchase ID column from the Redcat table, Redcat database, purchase ID, purchase item, and then we would like to join it to the purchase table on the purchase ID column where employee ID is 61 from the purchase table, and then the purchase date from the purchase table is between these dates. Again, I myself prefer the first one. But if you run both, you can see that the result is the same. This one, delete from purchase item 61 the record for manufacturer whose ID is 630. Super easy. Delete from the table that we just created, purchase item 61, where purchase ID, we need to have the subquery for it. In select purchase ID from purchase 61, where manufacturer ID is 630. So you tell me if you would like to just delete from the purchase 61 table, not purchase item 61 table. The first one that we created, this one. Purchase 61, okay? In that case, do we need to have the again subquery or we don't need to have the subquery? Let's say delete from purchase 61 where the instead of manufacturer to have the purchase ID, in that case we don't need it because there is no manufacturer ID in the purchase table. If we just had one purchase ID, we could. Sorry, it was there? Oh yeah, so again, we don't need it. No, we can just simply, where is it? You can just simply say, okay, delete from purchase 61, where manufacturer ID is 630. That's it. Yeah. So let's go to the view section. Create a view of all data in manufacturer table, but only include data from manufacturers in Ohio, India, Michigan, Illinois. Name the Midwest, named it as a Midwest manufacturer. So the function for this is again create view. The name is Midwest manufacturer, and then we have to put this as and then select all the column from Redcat manufacturer where state is Ohio, Indiana, Michigan, and Illinois. And also one of the reasons that I'm showing you this thing because I would like you to later go back and watch the videos and again listen to the all the instruction and then try to, in that case, if you need help. Otherwise, make sure to just run these before watching the video. And again, I don't care about your grade, even though you said it's debatable. So I just need you to just practice. Okay. The second one. This is all this it has just 3 sections. I'm just giving you all the answer. But I need you to just practice. Create a view from the customer from New York who have purchased more than $200 of product, not including tax or shipping. Name your view, Fave New York City customer, include all customer table column. So we are creating a new view. What is the view name? Favorite New York customer, as selecting all the columns from the Redcat customers. But we need to have those that their purchase value is over $200. So in this case, I would say where $200 should be less than whatever condition we have. The condition here is selecting sale price time quantity, which is the value of the amount of purchase for the customer. And also we would like to have the summation of it. from which data set? Sale item in the Redcat dataset, and then we are joining this one to the sale table. So sale item to the sale table, where customer ID is between the sale table and the customer table. And then the last condition is, and the state is New York from the customer. So as I mentioned last week, subqueries, there's nothing new in subquery. Subquery, you can just treat it as a normal query. But the only things that you need to understand is how to connect these two together. That's it. So right now, we can see that the result from this subquery is going to be some values. And then we would like to keep those values that over 200. That's it. And the last one, create a view of the manufacturer with more than 10 products, which have the list price of $20 or more. Include all manufacturer table column, name them as a favorite manufacturer. Again, the function create view of the manufacturer as select all the column from the Redcat database, the manufacturer table, where the manufacturer ID should be in some value. What are the values in this subquery? So this time, now let's see it as a new example. We would like to have those that the list price is which the list price of they have the over list price of the $20 and more. So in this case, oh, sorry, 10 products which have the list price of the $20 and more. So we need to count it. So in this case, again, we are selecting manufacturer IDs because we want to have the manufacturer ID from this subquery as a food for this above query. Okay, just I think it's a good example. You need to prepare food from one subquery for the main query. So the output of this subquery should be eatable for this one. If there is no connection between these two, so what's the point? So here we are extracting manufacturer ID. This manufacturer ID is the food for the main query. So from the Redcat product table, where we have to count those values, those rows that they have this condition. List price is over $20. So here it's gonna count those products that's over $220. So if there are more than 10 items, so then it's gonna be as the output of this subquery, which is gonna be for the food for the main query. So then we have the output. So as you see, I can say for sure that it's more complex than the first exam. It can be, it will be. So just practice, and again, don't stress for your grade, just practice and learn. That's the only thing matters. Make sure to go through all the assignments before the exam. Make sure to go through all the queries for the chapters, for each section. So run all of these, understand, read the book for sure, and it will be okay for the exam. So Wednesday, we are gonna work on the assignments of this section and try to again have a recap of whatever we had in chapter 6. And then you have almost 1 week. Just prepare for the second exam. Cool? No class Monday and no class Wednesday. No class at all, yes. So let me stop recording. See you next session. Okay, so welcome everyone. We are in week 12, second session. Let me pause. Okay, so technically we are finishing the chapter 6 today. So almost after 3 weeks, which we are done with the chapter 6. So today we are working on the last assignment, the 6.9, the section 6.9. And also we are gonna cover almost 10 example of the SQL code. So today is totally hands-on assignment. So this one is not posted in on D2L for this reason that we don't have access to the code while during the class. So just again, try to do the coding as much as you can with the assignment that we are gonna look, and then we will finish today class and next week the exam. Okay, cool. So before starting the coding, again, one more time for the last time. So this order of the statement is so important, as you already know. So we should always start with the select statement, then from a statement, and then if we have some logical condition, the where and the group by, which if you want to do based on the categories, and then having, and then order by. But the order of execution is from the from, then where, then group by, then having, then select, then order by. So again, this is the one that you should always remember how to deal with these statements. So let's see some examples. So make sure to have this advanced code editor open, Redcat 2, MySQL. Okay, so this is the database that we have, the famous one that we already so far worked. So if you want to have access to this one, also at the end of the 6.9 chapter, the assignment 608 is the graph is here. So you can also have that. But for the first one, so nope. List the customers who made purchases over $500 in total. Okay, so we would like to work with the customer table, sale item table, and the purchased over 500, which means we need to times the quantity by sale price of the items in order to have the total value of the purchase. Where is the okay. Okay, bad news. We just paused the recording. We already have been through 5 or 6 examples. No, I just paused the record when I went out. When I came back. So no worries. You have the file, go and check the file. So at least this one, display each product average sale price, it has been sold. But let's at least show it. So we talked about this one. We can pause and see. Then list the available items. So we have to use the, for example, quantity enhanced summation for the total quantity in hand. We talked about this one that we mentioned. We need to use the left join function because it's about those customers that have not made any purchases, and since we just wanted those items, we need to use the by default null. So make sure to run this one on your side. And top manufacturer, again, we talked about this. So we can also, for example, by adding limit tree, we can have the top tree. So this one is the one that we were just talking. So here we have the category and product and product. Also ignore and then product table to sale item table through the product ID as a foreign key primary group by whatever here. Here we have product group by all of these items and order by the category based on the what question asked. Okay. Good. List all orders made by customers. All corners thing. You talk about. We had something similar in the last session. Super easy, huh? Just customers from this state that they made some purchase. So we have to join sales table, customer table through the customer ID, where the state is the only point of this question is using in as the list. That's it. That's the main point of this question. Otherwise, it's a normal chapter 2 type of question. So select these, all these attributes, sale ID, customer ID, first and last name, which is it from the sale table and join into the customer. What are the primary key, foreign key, customer ID? There, the state is for the state. Boom. No, this one is ambiguous. These are ambiguous. These are not that much clear because these are the question I just created. Right. But no, over there they will tell you. For example, having the last name. No. So there is no point to having sale date on. No point having sale ID the output. Just the customer. So customer ID is enough. So wanted to show this is a very complex thing. Oh. What's that? In cap. Uncut, yes. Yeah, for joining. Well, yeah. You need to use it in a quotation. Then do we do that in yeah, you can use it. We call them as a scalar function. We have them. We have so list products that have a list price higher than the average list price in the category. Use software. Spend a couple of minutes on this one. Think about it. With the join is easy. You can do this. Just give me a second. Any suggestion for this one? Hmm? Just that the verb part is okay, it's right. Yeah. But what about the subquery? For the subquery, so one of you explain the logic of the code to me. So let me one more time. List products. So in a statement, whatever attributes related to the product have a list price higher than the average list price in their category. So this is important, in their category. Okay. So the main point here is we are using that subquery and name it as the average category. So here, the normal select statement from the product table, we need to join to we need to join, let me see, it's recording. It is. So the result of the subquery, what is the result of the subquery? We are going to have those category, those average of the list price that group by category. Okay. So we name it as a average category. And then we join that product table to this new alias, which is the average category by the category attributes. And at the end, this is the part that you mentioned. The list price should be greater than the average category price. then using not having, I mean, if you don't want to use the subquery, we have to use that average list price in the select statement, and then we need to group it by category, and then we need to have that having a statement when the list price is greater than category. But again, this is the subquery version. So we will have the result here. No, we didn't print. We can. Where is it? Uh, no, no. I don't think. No, the main point is we have to. Let me see which table it is. I think maybe we cannot. The list price is in what table? I don't think so that we can have it because that one already created by the subquery. Execute continue to user redcat for routine. So what's the issue? Denied to user. Weird. Weird, weird, weird. What is the issue? Mm, there's something with the subquery. That's why it doesn't let us. I think because it's already created by subquery, so there will be a conflict maybe. Once created from here, once created from here. That's why I used this one. What about this? I think this one is also doesn't work because this one. Oh, this one works. Yeah, because we changed that's why there was a conflict. We changed this average list price to the average category table and also name it as a average category price. So if I put it here, now we have it. So we can see that the list price is greater than the average category price. Okay. So I think this is the last one. Then let's go to the example. Show the maximum, minimum, and average of the shipping cost for orders made by customers from California. Simple. We know that about the orders by customers from California. So just three functions we need to have. Let's just don't spend time on it. Let me just run it on syntax. So maximum of the shipping price as a max shipping, minimum as a min shipping, average as a shipping, okay? And then from the sale, join to the customer table through the customer ID where state is California. And we have the aggregate function, but as we see, there is no group by because we don't have any other attributes. Yeah, it's all from the shipping, yes. We have the shipping attributes in the sale table. So technically just a normal join function, but using these three extra functions. Cool. Let's go to the assignments very quick. Sorry. The maximum shipping is 7.03, maximum minimum shipping, and also the average. Okay, so the last chapter, which is about the left join, right join, and outer join, which we talked, I think, last week about it. So the first assignment, it is. Yes, it is. Don't make me panic. No, it is recorded. Where? This one? No, the other side. Yeah, it's there. Yeah. No, I'm recording the whole screen always. So again, this is all recorded. Don't need to take a picture or something. You can just go back and watch it. List products, product name, product ID, whose list price is greater than 100. And how many sales, count, sale ID, and sale item there are for each product. Also include those have not been sold. Sort the output. You see here, also include those have not been sold. So we would like to see those that have been sold and those also have not been sold. If it mentioned that those that just have not been sold, we have to use that is null stuff. So sort the output data by number of sale item, name the column, no of sale. So product name, product ID, list price, its product exactly mentioned what it needs. And then at the end, it says that sort the output data by number of sale item, count function, name it as a number of sale. And then from product table, we should go to the, what about which table? The sale item table. But again, since it's mentioned that those that also have not been sold, we have to use the left function. Left function through the product ID between the product table and the sale item table, where the list price is greater than 100, group by product name, product ID, because with those, we have these two next to the count function, which is the aggregate function, order by number of sale. And maybe you have the question why we don't use having list price greater than 100. We are not allowed to do that because in the group by, it's group by based on this aggregate function, which is the count. So if we had this condition that the number of products greater than 100, then we had to use the having the number of sales greater than 100. But here it's different. Here it just gives us some condition which the list price is greater than 100. So we have to apply it before the group by. First assignment, the second one. List all manufacturers, ID and name, manufacturer ID, manufacturer name. Okay. From the manufacturer table, include manufacturers where no purchase have been made, include where no purchase have been made. Again, left function, sort the output by number of purchase, name the column number of purchase. Almost similar. Select manufacturer ID, manufacturer name from the manufacturer table, count the purchase ID, the number of ID that already purchased from the product table, name it as a number of purchase. Again, simple. From manufacturer table, joining to product table, what is the common key? Manufacturer ID, group by whatever here beside the aggregate function. Group by my manufacturer ID, group by my manufacturer name, order by number of purchase. Clear? Is it? How many times has each product in the flats category been purchased? Okay. Include those items that have never been purchased again. So you can now understand those type of questions that you need to use the left join function. Kinds of mentioning about, for example, item that's sold and also the item that have not been sold. So those part that usually always we don't address in the join function. In the left one, we will. So show product name, product ID. You see product name, product ID, clear. Sort the data by number of purchase, name the column of the counted purchase, number of purchase. Almost similar to the first one. From product table, we are joining to the purchase item table where the category is flat. This where category is flat is similar to the previous one where the list price is greater than 100. You're applying some extra condition before the group by. Which item should be in the group by? Those that are available next to the aggregate function. And then order by number of purchasers. Okay. So we are done this week. Let me start the recording.